Greetings. We are going to work now on the properties of special parallelograms. Let's go back and think about something that's been in previous discussion with us in this course. Okay, so got some malfunctions here. Let me see if I can just reboot this thing if it'll fix it right up. Okay, let's try again. When we have the quadrilateral that's drawn here, the default quadrilateral in your mind is this. I say, think of a four-sided figure. You typically think of the default one being the regular one, which is typical, right? When we think about the regular iteration of any polygon, the regular triangle is the equilateral triangle, right? It looks roughly like this, okay? We think about even like take the regular octagon, right? That's a stop sign. So it's a regular 8-sided figure. When we do that with the regular 4-sided figure, we actually call it a square, right? And it's not the greatest way to consider these things in a coordinate plane, because I think what we should start with obviously is that, is it a parallelogram or not? Okay. Once we have a parallelogram, we're going to start thinking of some specific instances of parallelogram. So for example, the first one we're going to discuss today is a rectangle. A rectangle, by definition, is a parallelogram with 4 right angles. That's just its definition. Okay? So, before I even draw this thing, I'm going to put out a few little bullet points. So we have a parallelogram. So if we have a parallelogram, and it is a rectangle simultaneously, right? So in order for it to be a rectangle, it has to be a parallelogram. If you were to find, for example, we were to test if something is a parallelogram or not, and go to the previous lesson, and remember what we had done is that our test for it was if the diagonals bisect. So it means that those diagonals share the same midpoint in a coordinate plane. If they don't, then it's not a parallelogram. If it's not a parallelogram, then it's not a rectangle. So this kind of takes us back to the very beginning of the course, where we produced a number of theorems, and we really rehearsed deductive logic, deductive reasoning on how to come up with a solution to something. Okay, so again, you're going to find a very logically linear sort of a flow here with how we're going to come up with some of our conclusions here. So if this is a rectangle, there's a few things that are going to be true. Then your diagonals are congruent. Then your opposite sides are parallel and congruent. Of course it is, right? It's a parallelogram. Then the opposite angles are congruent. Oops. Forgot to write then. So I should do that. And then also, the consecutive angles are supplementary. Also, so all these things are true. But here's the thing. The last 4 bullet points are all things that apply for parallelogram. Only one of these has a unique bullet point, which is that the diagonals are congruent. Okay? So that's something for us to note. Now, remember, think about what we're doing here. We're trying to consolidate and make the most efficient means of solving our problems here, right? So if within a rectangle, the diagonals are congruent, within a parallelogram, the diagonals share the same midpoint, we're no longer considering, right, because we're being deductive about this, we're no longer considering the sides, even though, or even the angles, okay? Even though what made this a parallelogram by definition was this, right? And then we can prove all sorts of other things about it. In particular, right, we have 4 right angles. And remember, if we have 1 was one of our bullet points going back, I think that's actually all the way here, right, 7.2. It's this. If you have 1 right angle, then you have 4, right? So going back in our notes. Yeah, if we have 1 right angle, then we have 4. So I don't even need to draw that, because in a parallelogram, the singular one's going to make all those consecutive angles and the opposite angle even, you know, the same. Just has to, okay? So, and some of this might seem logically repetitive, but it's also the way that we're going to be a little bit more elegant about these things, and we don't have to prove so much about it. The critical thing is that we're not even considering the sides and the angles. All we are going to consider with that figure, with that rectangle, is these diagonals. That's what we're going to be concerned with. It's a little bit of irony for us, okay? Next. A rhombus. A rhombus is a parallelogram. With 4 congruent sides. Okay? Now, same deal. Parallelogram is a rhombus. Then, we're going to say that the diagonals are perpendicular. Then each diagonal bisects opposite angles. It's kind of a little bit of a bonus. Not something that we can usually prove typically in a coordinate plane, but we're great at proving this guy in a coordinate plane, right? All right. Getting back to it. Then, and some of you guys are going to look at this and say, well, why am I writing all this again? Then opposite sides are parallel and congruent. Then, should I stop, right? Because look at what I'm going to do. All this is effectively, this is just, again, all of that right there, this just means it's a parallelogram. So if you want to stop taking these notes right here, right, I'm just going to copy and paste them, because, like, why would I keep writing these things again over and over and over? It just seems silly to me, right? It's just this, okay? What's unique here, okay? It's this. It's that the diagonals are perpendicular and the diagonals bisect opposite sides. So gentlemen, look at what's happening here. We're actually only concerned with ultimately the diagonals, okay? That's it. Now, I think you guys, I'm gonna take you guys through a little bit of a chart here in a moment about how we would prove these things. The textbook uses a Venn diagram. I typically don't. So I'm gonna take you guys through these tests of what we're gonna do if you're giving, coordinates in a plane, okay? Because some of this is gonna be pretty straightforward for you guys. Again, if you see something congruent, all you have to do is just copy down its measure, right? Or if, we've done enough of like opposite sides are, one side is 5x plus 2, and then the other one is equal to 4x, right? 4x plus 4, right? And then we solve for that, and to get x. I don't need you to run you through those exercises. It's going to be more important for us to do these following ones here. I want you to see that, again, if we have a parallelogram with 4 right angles and we have one with 4 congruent sides, then we're going to have one more thing, which is going to be a square, which it's a parallelogram still. Some more repeated reasoning. It's a parallelogram with 4 congruent sides and for congruent angles, or in other words, it is a rectangle and rhombus simultaneously. It's a very specific instance. So here's the tree I wanted to walk you guys through. Ready? Let's take the world of parallelograms. We have parallelogram. We have a quadrilateral, sorry. Okay, next. We see parallelogram. And it's going to be yes or no. Okay? If it's a yes, we have a couple tests to do. Okay? If it's a yes, we're going to say, is it a rhombus? And is it a rectangle? If it is a rhombus, yes, and it is a rectangle, yes, then your ultimate conclusion is that it's a square. But if we go down this tree, okay? Sorry, I drew this guy kind of crooked. Oops. So effectively we do this, quadrilateral, okay? Well, if it's a quadrilateral, we have to say if it's a parallelogram. If it's a no, you just go back here. This, by the way, you guys have seen these flow charts. These, you've seen them for sure on social media. These are always kind of like a funny social media joke. You'll see, like, is this question important? Then they start drawing these little flow charts. So if it's quadrilateral, okay, and you got to check if it's a parallelogram. The yes, no. If it's a no, you go back. You're just a quadrilateral, okay? If it's yes, then you're going to go and check both rhombus and rectangle. If it's a rhombus yes and rectangle no, then obviously it's just a rhombus, or vice versa, okay? It could also be no, no, and if it's no and no, it's just a parallelogram, okay? Or let's suppose that it is, let's see if I can, a yes and a yes, then you're going to get square, okay? So, cool deal. See a little flow chart here of how you guys can figure out what in the world you're dealing with. Now, here's what we're going to go through and talk about is our tests to figure it out. What's our parallelogram test? Okay. Again, it's going to be the diagonal midpoints. For the rhombus, it's going to be diagonal slope. And again, we're looking for it to be perpendicular. Here, for a rectangle, it's going to be diagonal distance. Okay? It's going to save us from having to do 4 different calculations. Now, there are other ways to do it, of course. I could figure out for rectangle, I could figure out if all the slopes are perpendicular. That's 4 slope calculations. Or I could do 2 distance calculations, okay? Or for the rhombus, I could do 4 distance calculations for the sides, or I can just do 2 slope calculations for the diagonals. I don't know about you guys. I think 2 less than 4 is the better way to go about this. So just food for thought there. Okay, so let's do a couple examples, and then I'm going to let you guys get to work here. in rectangle ABCD, AC is equal to 7x minus 15 and BD is equal to 2x plus 25. Find the lengths of the diagonals of ABCD. Here's my favorite part. I am never going to graph this thing. I'm never going to even draw it. Why would I draw it? I mean, you can. Sure, you can. Look, a quick sketch. Ooh, that's terrible. Quick sketch, right? Oh, come on. Fix it. Here we go. Oh, man, this thing's on strike. Come on. You can do it. There we go. Yeah, I could go A, B, C, D, right? And I see that these are your diagonals. Guys, I never had to do that, though. Look, go back here. If they call it A, B, C, D, it means that AC and BD are your diagonals. You just skip. They're non-adjacent. All right? So if that's the case, we'll think about rectangle. Go back. For a rectangle, the diagonals were congruent, okay? So it means that AC is going to be equal to BD. So 7x minus 15 is equal to 2x plus 25, okay? Subtract 2x from both sides. So 5x minus 15 is equal to 25 plus 15 plus 15. 5x is equal to 40, so x is equal to 8. Who cares, right? Here's the issue. It wants us to find the length of the diagonal. So in order to find AC, I need to take 8 and plug it back into either one. 7 times 8 minus 15, which is going to be 56 minus 15, which is going to be 41. Okay, ready? Last example for today. We're going to decide if quadrilateral ABCD is a rectangle, rhombus, square, or none of the above. Given the following coordinates, A is -2, 3, B is 2, 2, C is 1, -2, and D is -3, -1. Let's think about a little problem-solving deal, right? I'm never going to draw this. There's no reason for me to, right? All I need to do is, again, do I care about the sides? No. We need to check the diagonals. All right? So, first deal, let's figure out midpoint of AB, AC, and BD. Because here's the deal. What if this guy is not a parallelogram? If it's not a parallelogram, it can't be any of those, okay? Because go back to every single one of these definitions. Square is a parallelogram. Rhombus is a parallelogram. Rectangle is a parallelogram. So if we perform the parallelogram test and it fails it, right, for this quadrilateral, then the answer is going to be none of the above. So let's go and start with midpoints of AC and BD. Okay? And that's going to say, do we have a parallelogram? Then we'll check some other stuff. So here we go. AC's midpoint, BD's midpoint, -2 plus 1 over 2, right? And 3 minus 2 over 2. BD is going to be 2 minus 3 over 2. and 2 minus 1 over 2. So this guy's going to be negative 1/2, comma 1/2. This guy is negative 1/2, comma 1/2. Are these guys the same? Absolutely. Boom, we have a parallelogram. Let's keep going. Now we need to check 2 more things. We need to check the distance of AC and BD, and we need to check the slopes of AC and BD. The distance is going to determine if this is a rectangle, and the slopes are going to determine if it's a rhombus. Okay? Keep going. Let's do the distance of AC, right? Big square root, and then we're going to do the distance of BD. A, it's going to be negative 2 minus 1 squared plus 3 minus 2 squared, right? Which is going to be negative 2 minus 1 is going to be 3. Negative 3 squared is 9 plus 25, which is going to be rad 34. BD is going to be 2 minus 3 squared, right? Plus 2 minus 1 squared. I hope you can already see it. That's going to be 5 squared plus 3 squared, right? That's 25 plus 9. It's again rad 34. Gentlemen, it's a rectangle. They match. So this is what we're looking for with slope, though. Slope's a little bit different. Slope of AC and your slope of BD. Remember, we're not looking for the same slope. Same slope would mean parallel. That would be super hard to do in a as a diagonal in a polygon, in any polygon. It's impossible. You cannot have parallel diagonals. You can as long as they're not from the same vertex, right? But it's going to be, you're not going to ever have that in a quadrilateral, though. We only have 2 diagonals to deal with. You're never going to have that in a quadrilateral, okay? You may have that in other polygons, but not in a quadrilateral. So in AC, we're going to have negative 2, sorry, it's going to be 3 minus 2, right? Over negative 2 minus 1, which is 5 over negative 3. Let's go ahead and stop fixing that. And then BD, we're going to have 2 minus 1 over 2 minus 3, which is 3 over 5. Ooh, look at where we have that. We have AC is going to be perpendicular to BD, correct? Because those are negative reciprocals. We have a rhombus. So what is our conclusion? This guy here is a square. Why? Because after it passed parallelogram, it's both a rectangle and a rhombus simultaneously. Okay? Met all those definitions. If you have any questions, feel free to reach out to me. And your assignment is posted on Canvas. Good luck.